All right. Well, I am going to be talking about some different tools you can use to get more types of testing into your pipeline. And this is a presentation I'm going to be doing next Friday at Test Bash Philly. And it is an expansion on another presentation that I've done several times actually in different formats. But this is a new format for me, a 45-minute talk on this one. So anyway, talking about tests your pipeline might be missing, different tools you can get into your pipeline. And it isn't really so much about the tools as it is about the process rather. Looking for places and opportunities to do more and different types of testing that you might not already be doing. I'm going to skip over Coveros. Hopefully you guys know what that is and who our clients are, and go right to the delivery pipeline. So when I talk about getting tools into your delivery pipeline, I'm talking about the pipeline as the process for taking code change from developers and getting it deployed into production or delivered to customers. Or you could even be starting sooner than the developer as a requirement coming from the product owners, the stakeholders, right? They're giving you a requirement. That's really the beginning of the pipeline, right? And this could be done, this pipeline that we're building out, this whole process could be automated, right? In a true DevOps continuous delivery world, it's mostly automated at least. It could be completely manual, or more likely it's a mix of the two, right? Could be partly manual, partly automated. But either way, what you're doing is starting with a change and trying to get it into production or delivered, right? And really what that means is we're looking to see if we have a viable candidate for production, right? Is what we are building something that we are ready to go live with, right? So that's our whole goal, but it's not just as easy as saying, hey, let's just run the tests and keep going, right? We need to do a bunch of different types of tests. We need to do all sorts of checks to make sure that the thing is ready, and we can't do everything right up front. So how are we going to build that confidence, right? Can't do it all first, can't wait till the end to do all of it. We have to spread it out throughout our process. That's what makes our process. So my advice is do just enough of each type of testing early in the pipeline to determine if further testing is necessary, right? We want early rapid feedback so we're going to do the tests we can do fast and we can get rapid feedback on first, and they're going to probably catch the most things. And then if those work out, if we get past those, then we'll do some more testing, more in-depth testing that's less likely to catch the easy stuff since we've already covered that. All right. So if we're doing early rapid feedback in the beginning, right, we still need to build confidence, right, that at the end, we think it's going to pass. We don't want to get to the end and cross our fingers and say, hey, I'm almost ready, just one last test. Uh-oh, I'm going to need to start the whole thing over, right? We ran into a late surprise. So how do you do that? Well, you need to balance that early rapid feedback and avoid the late surprises and come up with some balance between the two. And you do that by understanding that you are going to have issues at the end, right? You're never going to get away from completely having surprises, but you don't want to expect them at the end. If you're getting to the end of your pipeline, ready for release, and you're expecting that there's problems, that's not a surprise, right? That's just a broken pipeline. So what we need to do is do enough testing up front so we get to that point and we say, hey, we're okay. We also have to do enough testing up front that when we get towards the end, we can afford to do the more expensive tests, the longer running tests, the tests that require more manual or specialized people, right? That involves a specialized performance team or needs you to get extra time on a performance environment that's scaled up a little bit bigger or something like that, right? Anything that's going to be more expensive, time, resources, or just effort, we want to push towards the end. But we want to do something before that of that type of testing so that we know, hey, we're not just wasting our time or we're not just shooting completely in the dark and crossing our fingers and hoping that this first performance test we run at the very end of our pipeline is going to be worthwhile, right? Do something up front ahead of that. All right, so remember, the whole thing is we're trying to balance early rapid feedback with no late surprises as we're building, or as we're going through our pipeline, looking to decide if we have a viable candidate for production, right? So let's start out with some changes. First thing we want to do is look at our code footprint. Look at the code we have, how much the libraries we're using, the code we're using, what we're pulling in, and just get rid of the stuff we're not using, right? It's a lot easier to start ensuring quality, securing, checking a smaller code base than a bigger code base. And since most of our software today is built with a lot of frameworks and a lot of third-party libraries that all get dragged in, one of the things you want to do is make sure you're not dragging in stuff that you don't need, right, and that you're not using. So if you're using something like Maven, you can use some of these commands up here: dependency tree, dependency analyze, and then there's another plugin that will look at the dependency versions to look for compatible versions. Just to identify any libraries that you might be including but aren't actually being used, right? And once you've cut down that code footprint and you're down to just the libraries you need, see if those libraries are up to date, right? Use something like OWASP dependency check to see if the remaining libraries have known vulnerabilities. Update any libraries that do, or at least make sure that something is keeping that vulnerability from being away into your systems, like a firewall, a WAF, web application firewall, some other type of mitigation that's, or control that is keeping you from letting that vulnerability be exposed or expose your systems. OWASP has had this using components with known vulnerabilities on its top 10 for a little while. It is what caught Equifax, right? And having something like OWASP dependency check in their pipeline, or if you're commercial, using something like Nexus, right? That has using the Nexus lifecycle or whatever they're calling that now from Sonatype, that can do that same type of check to identify components that you're using with known vulnerabilities, right? Or even what's using those vulnerabilities. Those are great tools to make sure that, hey, we're not using this version of Struts. We're not using this library that just had a bug announced about it, right? Some interesting stats from what Sonatype released, the state of the pipeline ecosystem, the software supply chain rather, that they released this year. In 2016, 5.5% of Java downloads had known vulnerabilities at the time they were downloaded, right? Not that they got downloaded and then someone found they had a vulnerability, but rather when they were downloaded, more than 1 in 20 of them already had a bug. They were downloading a bug into their system, presumably knowingly. All right. So once you've pared down your libraries that you're including and make sure your code's as small as possible from the for the libraries that you're including, the next step is to clean up your code, right? Poor quality code is harder to maintain than clean code. So start using things like static analysis tools, right? To look for security holes, to look for duplicate code block, style issues, declared but unused variable, confusing code, race conditions, SQL injection, resource leaks. All of that can be picked up by static analysis tools, right? And just by including them, you'll get a big win as far as being able to let developers get rapid feedback on the quality of their code and stuff they can fix, and it's all actionable stuff right away, early in the pipeline, okay? If you're not already doing any static analysis, go download SonarQube right away. It'll handle running all the static analysis tools for whatever language you're using. And it gives you an easy-to-use web interface that you can use to drill down into the problems, see what the problems are, and often given advice on how to go about fixing them. All right. Unit testing. I'm going to go out on a limb and say that unit testing is probably not one of the tools that types of testing that your pipeline is missing, or at least if it is, you didn't need to come to the talk to hear about that. But one thing to keep in mind is it is important for a lot of other types of tests. And one of those types of tests is mutation testing, all right? we have to make sure that the unit tests are actually testing the code. Just because you have them, a lot of times lulls people into a false sense of security that the code is completely tested. Well, there's a lot of problems with that. One is unit tests are checking that the code is doing what the developer intended it to do and not necessarily what it's supposed to be doing. That's a different type of testing, functional testing, right? But even if you're running unit tests, a lot of times people just use code coverage, right? Check what code was run while I was running the unit test. And that doesn't always tell you if the code was actually tested, right? So mutation testing tools will actually tell you if your unit tests are valuable, if any tests you should be doing are missing, right? Basically, it does what many people think code coverage actually does, right? And what it does is takes a copy of your source code, right? And then it will go in and modify that source code. So in this case, we changed an increment to a decrement. And then it just reruns your test as is. And if that if all those tests still pass, then obviously we didn't test whether that increment was actually working, right? Because we would have noticed it. That means that the mutation is said to survive, and so we know that scenario wasn't tested for or against, depending on how you think about it. So what mutation testing is doing is truly checking to see if your tests are testing the code. Here's another example, right? We just have a null check at the beginning of a method, right? Mutation testing might go in and change that is equal to null to is not equal to null and see if the test still passed. If that works and the tests if no test throws an error, then we know that we weren't testing that condition. That line is not truly tested. So I write Java code most often, so I use PyTest, PI-test from pytest.org. .NET developers could look at Ninja Turtles because, get it, it's mutating, so Ninja Turtles. Visual Mutator is another one that works for C#, .NET developers. Python has MutPy. Ruby has Mutant. There are a lot of projects out there for a lot of different languages. And mutation testing isn't out there without its drawbacks. It is slower than running unit tests. It is something you should probably want to do after your CI cycle runs, because it will take a little while, because these unit tests that you had before are getting run over and over and over. So it's definitely slower than regular unit testing, but it is really worthwhile, right? And the tools do a good job of figuring out what should be run over and over. I use mutation testing in my unit test, even if the project doesn't call for it, just to be sure I'm actually testing what I think I'm testing, or to make sure, if I have legacy, if I'm modifying legacy code and I see unit tests covering it, to see what edge conditions they're not testing, so that before I start refactoring or making changes, I know what I don't have a safety net for, and I have a chance to add that safety net beforehand, right? If you take nothing else away from this discussion, other than hearing me talk about and getting some interest in mutation testing, then I will definitely consider this successful, worthwhile talk. All right, another type of testing that you almost certainly are doing, and I mentioned earlier, functional testing, right? I think everyone knows what functional testing is and why it's valuable to use tools like Selenium or QTB, Test Complete, Robot, whatever, right? But you can also use functional tests in different ways other than just checking to see if the test passed, right? You can set up your functional tests to do user role testing, right? Test what users can do, or at least shouldn't be able to do, what they can't do, or what they shouldn't be able to do, right? For example, I should be able to see my account info, but not see someone else's. An admin should be able to see this menu item, but regular users shouldn't be able to see this menu item, right? When a logged in user goes to a page, it looks this way. If they're not logged in, it looks this way, that type of thing, right? And functional tests are a great thing to use for that. We did this on a DoD project with a lot of different roles. I think it was something around 14 different roles, types of users that could be in the system. And it ended up being hugely valuable. Not only did we get some great testing that ended up being a great basis for security testing later, but also it forced a conversation anytime we added a feature. We'd sit down with the BA and say, who gets to use this feature? How do the other people see it? What does it show up like for them if they can't use it, or how does it behave for them, right? And we ended up adding at least 2 functional tests every time we had a new feature, one for the haves and one for the have-nots. And just having that discussion, building up the matrix, forced that discussion of what the behavior was for each role beforehand, and sparked a lot of design discussions right there. So that was a great benefit we found from focusing on user role testing with our functional tests. Another thing that functional tests can be really good for is piggybacking security tests on them, right? If you throw something like OAuth Zap in as a passive proxy while you're doing your functional tests, you get some extra security testing for almost no effort, right? You're just running the functional test, you're running regression tests, you're just pumping traffic through the scanner, and you're just quietly watching in the background, looking for things like cross-site scripting vulnerabilities, cross-site request forgeries, SQL injection, anything like that. It works for automated functional tests, but it can also work for manual testers, and actually is a really good thing to have set up for the manual testers if they can do it. Proxy their browser as they're doing their exploratory testing, because they're going to hit pieces that your automated tests won't. They're going to add input that the fuzzers that the functional tests are not going to automatically put in, right? And there's a lot you can do with that. It's just an easy way to get some extra security testing in just by using a proxy. Another thing to look at is testing the APIs that you depend on, right? You can use tools like SoapUI or Postman to proxy some of your requests and to tweak the requests and responses so you can start getting some, see what some of the odd behaviors are. What happens if I get back a broken response? What happens if I send data that's not quite right? How are they going to respond, right? And a lot of times it's hard to do from the app, but it's easy to do if you can intercept the traffic going through, right? You could use OAuth Zap to do this too, but these tools are specifically set up to handle API testing. Along those lines, once you do some testing on the APIs, on external APIs that you use, you might want to mock them, right? So you can do better error case testing and faster tests. Once you've modified to see what a bad request will generate, I can see if I can handle the response that would come back from that. And I can do that with a mock so that I don't have to worry about that system being available or up all the time. And tools like WireMock, Hoverfly, Postman, Mockable.io all let you set up virtual service that can return either canned or dynamic responses to the service calls that you're testing. So you can do that testing without them being up and available, or you can do it, like I said, to invoke oddball conditions or error conditions, right, where they're saying, hey, we're down for maintenance. So I throw a valid response to them, but I get back an error response that I might not normally be able to generate, right? One thing to do, though, is if you're mocking those, don't forget periodically to go back and make sure that those simulated responses that you're sending still match reality, right? Make sure they're still doing what they're supposed to be doing and behaving the way the actual service behaves. All right, another thing to do is look at what the users are doing, right? Watch analytics and logs. Are there a few things that users are doing quite often, right? There's some sort of 80-20 rule, the Pareto principle, right? Make those a priority, those functions priority when you're doing your testing or optimizing. Are there errors that are showing up more and more often? Did a recent release or recent feature push go out, generate a lot more errors, a lot more traffic, right? How has that change been received? What are the effects of it? Watching your logs, making sure you have a way to go back and check the analytics is a great way to see if you actually have bugs or UI issues or actual problems in the system. Make sure you can do repeatable, reliable deployments, right? Make sure that you can deploy over and over the same way in every different environment you have, whether you're talking about doing Docker for containers or you're using Chef, Ansible, Puppet, something like that to deploy onto a system and do automated deploys, or whether you're using something like Packer to build images. You want to make sure that those are repeatable, and you're going to test that by using that every chance you get. Now, it doesn't sound like it's straight testing, but what it will do is it'll give you a lot of opportunities to try that deploy if you use it to set up demo sites and to set up your test system and to set up environments on the developers' laptops or the testers' laptops, or however, just so that that gets run over and over. So that way, when you get to production and you do your deploy in production, you know it's going to work because you've run this over and over in the past, right? It's not the first time that's happening. And what a side effect is this is that you'll start having more and more reasons to stand up new environments. You need a demo? Great, we'll stand up an environment for you. You want to run a 24-hour soak test? Sure, I can give you a system that can handle it without impacting all the work that's currently going on, right? And here's a big one. What happens if the system goes down? Right, we just lose, crash, hardware failure, something like that. Don't worry about it. We can set up a new one in a new data center and the other side of the world will look just like this one, and we know that because we have repeatable, reliable deploys, and we've been testing that and making sure. Part of testing those deploys is to check that the deploys worked. So do smoke testing, or as some of the classes I've taught have called it, the deployment verification checks, right? After every deployment, a quick check, just checking that the deployment worked. Do my interfaces work? Can I connect to the database on the back end? Are my credentials right for my external services that I'm connecting to? Just checking basic signs of life and configuration settings, not the functionality. We want to keep this nice and short because every time I deploy, whether it's to the developer's laptop, to the test system, to a staging system, to a production system, to a COOP site, I want to run that smoke test to make sure that everything came up the way it's supposed to and I know it's working. And then if I want to go on and do testing, you know, if it's a test site, I can actually do my real testing and know that it's going to be valuable. It wasn't that every test I run from here on out is going to fail because the deploy didn't work in the first place. Right? All right. Now, once you start deploying, there's other things you want to look at, right? Are all your packages up to date? Just like we used OWASP dependency check in the beginning to check the libraries, once you start deploying out to systems, you want to make sure those systems are up to date, right? Use the services that are built into the OS to make sure that you're getting up-to-date packages, right? And that way you can act proactively rather than reactively when somebody comes and says, hey, we need you to make this change. You can't go into the data center. You can't go live with this broken package attached to it, right? Stuff like Heartbleed or any of the popular vulnerabilities that have been detected. One thing that's worth doing as well is to subscribe to the US CERT Weekly Vulnerability Summary. It's an email mailing list that comes out once a week on Monday evenings, Tuesdays, and just tells you what bugs were found in the last week. You can just scan through it quickly and see, are there any packages that we use, that we rely on, that just had a new update pushed out because of a security vulnerability, right? There's a lot of advantages to doing all this, right? You stay ahead, like I said, you stay proactive, you're not reactive to the package changes coming in on your system. But the other thing is, if you can keep up to date with just the regular updates, right? Go from 2.1 to 2.2 to 2.3 and so on, as the changes come out, usually those are nice small changes. They have very little impact, if any, on the code that you've written to use it, right? On the other hand, as soon as a new feature comes out or the end of life the version that you are using, or it no longer works with the version of Java that you're using, or whatever the case is, and you're forced to update, if you have to jump from version 2.1 to version 6.5, sometimes that can be really painful, right? It means a lot more work, a lot more churn, a lot more disruption. So it's worth staying up to date with your packages and checking to make sure that you're staying up with those. Protect all your systems against hackers, right? There's no such thing in the cloud as just a development server that doesn't need to be secured. Just treat everything attached to the internet like it's a production system, because hackers will try to get in. Not because you have state secrets or nuclear launch codes on your site necessarily, maybe you do, but they just want someplace they can use for a zombie botnet. They want someplace they can host to send spam from, to use as a mail bot, right? Or even just to mine Bitcoin. So use some of these tools just to protect your systems and make sure that they're staying up so that you don't get into problems with the rest of your pipeline. Fail to ban will protect you against brute force attacks. AID is considered a file integrity monitor. It's like Tripwire, to see if anything on your system has been changed without your knowledge. OpenSCAP will tell you if all your systems are meeting the Secure Technical Implementation Guidelines, right? Just a series of best practices published by the DoD or NIST, depending on where you get them from. just seeing if you've locked down your system as much as you can. And don't forget to use these same tools, not only on the systems that you're deploying to, but on your infrastructure, your CI server, your source code management system, your issue tracker, right? Any of those systems, if they're exposed to the internet, you should be checking them and making sure they're protected as well. Use something like Chef Inspect to do your audits, right? Even if they're not going to replace an official audit that has to happen before you go live because you're in some sort of regulated environment, it's worthwhile to set up some automated checks that can check that you're expecting that you're going to pass your audit at the end. Remember, we don't want any late surprises. So by doing an early check, by writing code that will do it, and we can run this through every deploy, we can check that our systems are up to date and we're meeting our compliance requirements, right? If you have to use STIGs or comply with DSS, PCI, or something like that, this is a great way to get confidence earlier in the pipeline that you're not going to fail your compliance audit at the end. Once your systems are all set up, don't forget about the database. SQL Map can look through the front end, web front end, to see if you have any SQL injection problems. See if an end user could just go through your website and get control of your database, modify your data, whatever, without ever getting command line access to the system. DB Unit is great for setting up test data and comparing results. JMeter is great for performance testing the database. I've used this when I was adding audit logs to see if we can meet the STIG. We actually use PG Badger, which analyzes database logs for Postgres. There's different versions out there for MySQL and other databases. But we just found out what most queries were running, what queries were running most often. I mean, we wrote a series of tests in JMeter to test directly to the database and see how fast those were run. We didn't use it like a full-blown performance test. We just did a quick 15-minute test. And as we added more and more logging, we just looked to see if it was slowing things down noticeably, right? Or were there ways we could tweak the auditing, or make the auditing asynchronous, or later on do an analysis to get the same audit logs that we wanted in order to make sure that we weren't slowing things down just by trying to secure it. Speaking of performance, there's other things you can test with performance. Like I said, with JMeter, the same thing you did with, I mentioned with the database, you could do with your web server logs. Look at what the web servers are doing. Look on the web servers to see what the users are doing, and then write some JUnits to do a quick performance check, just to see how long it takes, in a 10-minute cycle normally, if you've made some changes, things are slowing down, right? Does it all of a sudden become 11 minutes, 12 minutes, right? Is it creeping up, or is it you add one feature and all of a sudden there's a huge jump, right? Just do some. Watching the trends can be very important, and just doing some performance testing early can really make it worthwhile to get to the end and do that full-blown soak test, or the full-blown load and performance test by the other team, or just it takes days to do, or requires a high-end system to have it set up and do it. If you just know things haven't been getting slower, you have confidence by the time you get to the end that everything's going to be okay. Remember that none of these tests, like I was saying, have to be full-blown, right? Early checks can be helpful. Like I said, if we're doing at the end a full load and performance test in a dedicated environment, production-side servers, maybe it's a 4-hour test with 1,000 current users, and we're trying to figure out what our sustained capacity and throughput is, maybe early on we want to do a short JMeter test, right? Just on the development system, we don't even bother with any isolation. We just do 10 users for 10,000 requests and just track the trend. Are we getting slower or faster? As long as we're not getting slower and we passed our last full load of performance test, well, we know we're pretty good, right? We're unlikely to fail at this time because we've been getting faster, or we haven't been getting slower. Same goes for security testing, right? If at the end we have this full-blown, test by this corporate security group that uses HP Web Inspect and Nessus, right? It's looking for black box web vulnerabilities. Do we have any cross-site scripting, cross-site request forgery, that type of thing, or looking for open ports, software with known vulnerabilities, right? We're looking for compliance. Maybe early on we can do something with cheaper systems or open source systems like OWASP, right? Like I said, piggyback on the functional test. Do we have any cross-site scripting vulnerabilities, or with OpenVAS, which is an open source fork of Nessus. But we could run that early on in our pipeline, just weekly or something like that, looking for those same things. Really just telling us, is Nessus likely to find anything when we get to the end? And through all of that, keep in mind that there's a lot of different non-functional tests, right? I'm not going to read through all of these, but non-functional tests are almost always underrepresented in your testing suite, right? Pay attention to them. Take a look through this list every now and then and just see, are there tests that we're missing that would be really important? Have we been burned by not having done one of these types of testing before? Maybe we should try to figure out a way that we put one of these into our pipeline. Right? Such as maybe recovery or failover testing, right? Things are going to break. You're never going to recover gracefully from a failure or a system crash if the first time you have to try is with users crying and management screaming in your ear, or vice versa, with users screaming and management crying in your ear, right? Practice failures so that recovering from them becomes second nature, right? This Netflix Simian Army is pretty popular, pretty famous for doing some of this, for creating scenarios where things are failing on a regular basis, just so that you can go in and practice recovering from it in a controlled manner, right? And once you're doing this multiple times a day, recovering from a system outage, well, then when it really happens, nobody's panicking. Everyone knows what to do. They've been doing this over and over. And lastly, remember to test that your pipeline, the tools, the systems that support it, all that infrastructure, that's how software gets developed. That is going to become critical infrastructure very quickly. So test it. Make sure that changes on your dev pipeline make sure that you're making those changes to your delivery pipeline in a dev system before you push it out to everyone, so that it doesn't stop everybody from rolling out their software. You don't want to prevent anybody from releasing software because you updated Jenkins and now no builds work, or you added a new plugin that's stopping everybody from getting their work done, right? If it goes down, software delivery teams grind to a halt. So you need to test your pipeline and make sure that is treated like production, like critical infrastructure. So hashtag Coveros5 is our company's term for the 5 most important takeaways from a talk or a blog post. Anytime we publish something, we send out tweets with these. So the 5 things that I think were the most important from these were, first, the pipeline is about building confidence that you have a viable candidate for production. Add tests with that in mind. Next, do just enough of each type of testing early in the pipeline to determine if further testing is justified, right? Balancing early rapid feedback to avoid no late surprises, right? Can't do everything first or last, some sort of balance, but make sure you're doing some of each type of testing early on, so that by the time you get to the end, you have some expectation that will work. Mutation testing, like I said, that's one of my favorite topics. Use mutation testing to make sure that your unit tests are actually covering what you need covered. Your unit tests aren't missing huge edge conditions, or aren't pretending to test the system but not actually doing any testing of the code. It's all testing the mocks, stuff like that. Some testing is better than no testing. I mentioned doing some of that JMeter testing early on, right? Just watching those trends, just doing a quick test just to see, hey, are things generally getting faster, slower, or doing a quick security scan to see, hey, are things basically looking pretty good? I don't have any major obvious holes that are going to stop my full-blown security test at the end, right when they get started. They'll just say, hey, this won't go. Watching those trends, watching those early token tests can be really valuable. And lastly, the last of the 5, continuously improve. Don't expect to ever be 100% done. Always look for new opportunities to add more testing to the pipeline. These don't have to be big, sweeping changes. A little bit better is still better. A few extra checks here, a faster test there, it's all going to add up. A little better is still better. Keep improving. And that is it. And that was almost the same length as my 10-minute talk that went on for 20 minutes. Because this one, I think, went on for 30. About.
Yeah, I think I had you like 32.
A little more. Okay, so I can go a little bit longer. Just skipped over the Coveros.
Right.
That's another 2 minutes or so, and I can talk slower on some of this stuff.
Were you going to give an intro about yourself?
I'm sorry?
Were you going to talk about who you were in addition to who Coveros is?
Not usually. I usually just say I'm a developer at Coveros while I have those slides up.
Yeah, I mean, I think overall your voice track was at a fairly fast pace. So knowing that you have time, I think it'll allow you to kind of pace it out and slow down a little bit. You know, hopefully a couple people will ask questions. You can wave and gyrate at people, that kind of stuff.
Yeah, I do have to have the time for questions built into the 45 minutes. So I do need to come in probably right around 35, 40, somewhere in there. So anything else? You were making notes, Jonathan.
You already noted that the 2 slides would give you more time. And then just one thing at the end, you said avoid no late surprises, which actually means you want late surprises.
Yes, avoid late surprises. We're trying to balance that. Okay. And I did this talk on this page. I did everything I wanted to talk about there. Okay. Well, thank you guys for bearing with me running through this. I hope you're not too disappointed that Glenn wasn't talking.
No, I was pretty